Hello, and welcome to Relaxing Facts. I am Chad K, and today I will be talking about the dark side of the moon. Each week, I share interesting stories and little-known facts on a variety of topics, accompanied by gentle, soothing music. My goal is to help you find a sense of calm during your busy day. Feel free to settle into a cozy spot and let yourself be carried away by these relaxing facts. When people hear the phrase, the dark side of the moon, they often imagine a permanently shadowed hemisphere drifting in eternal night. In reality, the moon does receive sunlight on all sides. What is commonly called the dark side is more accurately the far side of the moon, the hemisphere that always faces away from Earth due to tidal locking. This simple orbital relationship has created one of the most scientifically intriguing, culturally misunderstood, and historically mysterious regions in our solar system. To understand the far side, we first need to understand why it exists in this form. The moon rotates on its axis at almost exactly the same rate that it orbits Earth. This is not coincidence. Over billions of years, Earth's gravity slowed the moon's rotation until it became tidally locked. The result is that one hemisphere, the near side, always faces Earth, while the other remains permanently out of direct view from our planet. From Earth, we never directly see the far side. That absence of visibility is the source of its mystique. For most of human history, the far side of the moon was pure speculation. Ancient astronomers mapped lunar features in great detail, but only on the visible hemisphere. The far side became a blank canvas for imagination. Some thought it might be covered in vast oceans like the near side's mare regions. Others imagined alien civilizations hiding out of sight. Even early scientific thinkers could only guess. The moon's synchronous rotation meant that no telescope on Earth, no matter how powerful, could reveal what lay beyond the edge. That mystery began to dissolve in 1959, when the Soviet spacecraft Luna 3 transmitted the first images of the far side. The photographs were blurry by modern standards, but they were revolutionary. For the first time, humanity saw a completely unknown landscape. What appeared shocked scientists. The far side looked dramatically different from the near side. The near side of the moon is dominated by large, dark, basaltic plains called maria, formed by ancient volcanic activity. These smooth regions create the familiar man-in-the-moon pattern visible from Earth. The far side, however, is almost entirely different. It is heavily cratered, rough, and lacks large maria. Instead of smooth plains, there is a rugged, ancient crust saturated with impact scars. This asymmetry is one of the biggest geological puzzles in lunar science. One of the most striking features on the far side is the South Pole Aitken Basin, one of the largest and oldest impact structures in the entire solar system. Stretching roughly 2,500 kilometers in diameter and several kilometers deep, it is essentially a colossal wound in the moon's surface. Scientists believe it was formed by a massive asteroid impact early in lunar history. Studying this basin offers clues not only about the moon's evolution, but also the early solar system itself, when large-scale collisions were far more common. But why are the near and far sides so different? The answer likely lies in the subtle differences in crust thickness and internal heat distribution. The near side's crust is thinner, allowing magma from the moon's interior to erupt and form basaltic plains. The far side's crust is thicker, making it harder for lava to reach the surface. As a result, volcanic activity concentrated on the near side, while the far side remained more primitive and heavily cratered. Another factor may involve Earth itself. Some models suggest that early tidal heating and gravitational interactions influenced how heat was distributed within the moon. Earth's proximity could have caused one side of the moon to retain more heat, contributing to uneven volcanic activity. While these theories are still being refined, they highlight a key point. The moon is not a uniform body. Its history is shaped by complex interactions between internal geology and external gravitational forces. From a scientific perspective, the far side is also uniquely valuable for another reason. It is one of the most radio-quiet places near Earth. Because the moon blocks radio waves coming from Earth, the far side is an ideal location for radio astronomy. Earth is filled with radio noise from communication systems, satellites, and electronic devices. On the far side, scientists could potentially build telescopes capable of observing the universe at low radio frequencies that are otherwise impossible to detect from Earth. In a sense, the far side is a natural shield, offering a pristine window into the early universe. This idea has inspired serious mission planning. Organizations like NASA and other international partners have considered or already begun missions targeting the lunar far side for scientific infrastructure. In 2019, China's Chang'e 4 mission achieved the first soft landing on the far side, deploying the Yutu-2 rover. Because direct communication with Earth is blocked, a relay satellite had to be positioned in orbit to transmit data. This technological workaround underscores one of the far side's defining characteristics. It is not just distant, it is isolated. Isolation is also what gives the far side its cultural symbolism. In popular imagination, it has become a metaphor for hidden truths, unknown territories, and psychological depth. This is reflected in music, literature, and philosophy. The phrase, "dark side of the moon," though scientifically inaccurate, persists because it resonates emotionally. It suggests something unseen yet real, something permanently out of reach but still part of us. However, scientifically speaking, the far side is not dark at all. It experiences the same cycle of day and night as the near side, with roughly 2 weeks of sunlight followed by 2 weeks of darkness. Temperatures swing dramatically, from extremely hot during lunar day to extremely cold at night. Without an atmosphere to moderate heat, the surface environment is harsh and unforgiving. Any future human presence there would require advanced shielding and life support systems. Despite its harshness, the far side is a treasure trove for planetary scientists. Its surface preserves some of the oldest and most unaltered records of lunar history. Because it lacks extensive volcanic resurfacing, many craters remain intact from billions of years ago. Studying these features helps scientists reconstruct the timeline of impacts in the early solar system, offering insights into how planets like Earth evolved under constant bombardment. The far side also challenges our understanding of planetary symmetry. In most celestial bodies, geological features are relatively evenly distributed. The moon is different. It presents a striking case of hemispheric asymmetry, where one side tells a different story than the other. This has implications for how we understand planetary formation in general. If one small moon can develop such a split personality, what might that imply for larger worlds? Future exploration aims to answer these questions. Missions are being designed to drill into the South Pole Aitken Basin, sample deep crustal material, and possibly return samples to Earth. These rocks could reveal what the moon's interior is made of and how it cooled over time. They may even help refine models of Earth-Moon formation, including the widely accepted giant impact hypothesis, which suggests that the moon formed from debris after a Mars-sized body collided with Earth. In addition to science, the far side may also play a role in humanity's expansion into space. Its isolation makes it a candidate for future observatories, communication hubs, and possibly even lunar bases shielded from Earth's interference. Yet that same isolation presents challenges. No direct line of sight to Earth means dependence on orbital relay systems, and the terrain is rugged and unpredictable. Ultimately, the far side of the moon is not a place of darkness, but a place of contrast. It contrasts light and shadow, familiarity and mystery, and accessibility and isolation. It is a reminder that even in our closest celestial neighbor, there are still vast regions that we have only recently begun to understand. That brings us to the end of this week's talk. If you liked this episode of Relaxing Facts, please subscribe, or click like. I hope you have a wonderful rest of your day, whether you're taking a moment to unwind or just simply enjoying some calming listening. Thank you so much for being here. I am Chad K, and I look forward to seeing you next time. Bye.